and common log. So as we talked in the previous video, converting from logarithmic form into exponential form. For instance, if we have a log base a of n is equal with x, logarithmic form, and we convert into the exponential form, is n equal with a in exponent x. So base here is a, and here in exponential form the base is a. So x is an exponent. So the common logs are the logs of the base 10. For instance, if we don't see here anything that has in the base, we already know this is the log base 10 of n is equal with x. And when we convert in exponential form, n is going to be 10 in exponent x. Natural logs are denoted with a ln. And when we have a ln of n is equal with x. And now n is equal with e in exponent x. E is the Euler constant, as we talked earlier. So now, if we have a ln of x equal with y, so there is the formula so that says ln x is equal with log base e of x. And now, for instance, instead of ln x, we are substituting log base e of x. And if we try this one, just let's see, can we convert this in the exponential form? So now, instead of ln x, I am substituting log e of x. So here is log base e of x is equal, so instead of ln x, I am substituting log base e of x, and in other side is a y. Is y here. And now when we are converting into the exponential form, x is going to be equal, e is a base, so in exponential form it means e is a base, and y is an exponent. So what we already have here. So it means when we have a ln x equal with y, so x is going to be equal with e in exponent y. So this is the form how we can convert from the natural log into the exponential form. Let's take some example now. It says evaluate common and natural logarithms. What is the value of each logarithmic expression to the nearest 10,000th? So we have a log 47. Log 47, because here we don't see any base, we already know this is a common logarithms. So let's try to calculate in a calculator. So here is a 47, and common log is a log with a base 10. And here we have 1.6721. So this is equal with 1.67, and let me see the other decimals, because as 4 in the is a 21, because we have to find in the 4 decimals these numbers. That's what they're asking the question. And now we have to find this ln 2e. This ln 2e, it means this is a natural log. And to find in a calculator, we go this way. First of all, 2 times e, 2 times e is here, and we get the value, and we go into ln, and we get 1.6931. So 1.69, 31. So we get in the 4 numbers after the decimal point. So it means to the nearest 10,000ths. And log 1 we can calculate even without a calculator. For example, if we have a log 1, let's say log 1 is here, but we have, this is a common log, and it means the base is a 10. Log base 10 of 1 is equal to what? We don't know what is. So let me write x. And now if I am converting this into exponential form, 1 is going to be equal with a 10 in exponent x. And now I'm looking at this here and I'm trying to identify what gives me 1. 10 in what exponent gives me 1? If x is 1, 10 in 1 gives me 10. But in a 0, anything in a 0 gives you 1. So 1 is equal with 10 in exponent 0. So that's why this expression here is going to be equal with 0. But if we want to use calculator just to make sure we did it correctly, we can take this 1 and log 10 gives you 0. So we already proved and we found all the results.